Hello students, today I am going to explain separation techniques, how to separate homogeneous and heterogeneous mixture. This video is designed for 9th grade students. We are going to separate mixtures of potassium chloride and ammonium chloride, common salt, water and sand, kerosene oil, water and salt. Last separation will be mercury and water. Let's explore it. We are going to separate potassium chloride and ammonium chloride mixture. In a beaker we have taken KCl and ammonium chloride mixture. KCl and ammonium chloride both are white powder, but for our understanding we have drawn ammonium chloride as a black powder and KCl as a brown powder. Now top of the beaker is closed with a funnel and top of the funnel is closed with a wet cotton plug, and the entire setup has been kept on a hot plate which we use for heating. Now here when we start to heat this mixture, ammonium chloride undergoes sublimation and KCl remains as a solid. When we start to heat this mixture of potassium chloride and ammonium chloride undergoes sublimation. That means it directly converts from solid to gaseous form. Now when the gaseous ammonium chloride come close to this wet cotton plug, it started to deposit as a white solid on the top of the funnel and KCl remain as a solid in the beaker. This is the way we can separate the mixture of potassium chloride and ammonium chloride. Next separation is mixture of common salt, water and sand. This beaker contains salt water and sand particles. Sand particles make a heterogeneous mixture. So here we need a simple technique which is called filtration. Here we have taken a funnel. Here we can keep filter paper or we can close the funnel with a cotton plug. Now if we start to filter it, sand particles collect inside the filtered paper and salt water collects in the beaker. So this is the salt water which is a homogeneous mixture. Now when we start to heat the salt water at 100 degrees Celsius, water evaporates completely and the salt remains as a solid in the beaker. We also can explain this separation by writing this kind of flowchart. When we filter it, sand collect as a residue on filtered paper and as a filtrate we collect water and common salt. Now we have to heat this mixture. Water boils and leave as a gas and common salt remain as a solid in the container. We have to separate the mixture of kerosene oil, water and salt. The entire mixture we have to take it in a separating funnel. Now this is a separating funnel. Here the higher density liquid will be in the bottom layer and lower dense liquid will be the top layer. So kerosene oil has lower density than salt water. So kerosene oil is on the top layer and salt water in the bottom layer. So we have to collect the bottom layer in a beaker. So this is the way we can separate kerosene oil from water and salt solution. Now as usual we have to take salt water solution on a heating plate and we have to heat it at 100 degrees Celsius. Water evaporates completely and salt remain as a solid. We also can explain this separation using a flowchart. First we have to use separating funnel. Kerosene oil will be top layer, water plus common salt will be bottom layer. Now we have to collect the bottom layer and we have to heat it. When we heat it, water boils and leave as a gas and common salt remain as solid in the container. We have to separate mercury and water mixture. Mercury has more density than water, so mercury deposit on the bottom of the beaker. So here we need a simple decantation process. For that we can use a funnel. Inside the funnel we can keep a filtered paper and or we can close it with a cotton. Now we have to filter it or decant it. Then mercury collects inside the funnel and water collects inside the beaker. So this is the way we can separate the mixture of mercury and water.